Sir, did you do this question? This one, B part. How much current will an electric heater coil draw
Yes, sir.
from a source? Very good. So I'm going to revise the last class lecture. We studied about Ohm's law. And what does Ohm's law say? Potential difference across two ends of a conductor directly proportional to current. And to remove this proportionality sign, here will be R, and R is basically resistance. And we can also write V is equal to IR. This is Ohm's law. Then we studied about factors on which resistance depends. So we saw that resistance directly proportional to the length of the wire and resistance inversely proportional to the area of the cross section. Also, this R is basically property of any conductor which oppose the flow of current, So after combining these two equations, equation number 1 or equation number 2, we got a final equation, that is R directly proportional to L by A. And to remove this proportionality sign, we got rho, and this rho is known as resistivity or specific resistance. I also told you that unit of R, that means resistance, unit of resistance is ohm. And what is the unit of rho? Can you tell me what is the unit of rho? Resistivity.
Don't know, sir.
Harsha, what you just said?
Sir, I don't know.
You don't know. Whenever questions on unit will be asked, you just need to know the formula of the following, like R is equal to rho L by A. Now, what we will do is find a formula in terms of this. So for rho, it will be A by L into R or not. Can I write this? Yes or no?
Yes, sir.
Now, you know the unit of area is meter square, and unit of length is meter, and unit of R, that is ohm. Now you can cancel this. So the unit of resistivity will be ohm meter. Got it?
Yes, sir.
Very good. Just write. So the unit, the question in terms of unit is very important.
Done, sir.
Harsha, am I audible?
Yes, sir.
Very good. Are you done with this unit of resistivity?
Yes, sir. Done.
Okay. Now we will do some questions from the last class topic, like write a question. The potential difference between terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? Please do this question. Wait. Can you solve it?
Sir, I'll try.
Okay, just write, then I will explain it if you won't be able to solve it.
Sir, the resistance will change with potential difference.
No, resistance in a wire is fixed until or unless its length or area is changed. Okay, or
Okay, sir.
by means of other things. So you can calculate resistance with the help of potential and current, right?
Yes, sir.
So that resistance will be fixed, and here the potential difference is increased to 120 volt. That means resistance is given that you have just calculated, and potential is already given. So can't you calculate current?
Yes, sir.
Very good. हमना हमना am I audible to you?
Sir, 8 ampere.
Very good. So what you just did is, it's very easy, very good. You have done it. The potential difference PD is basically 60 volt, and the current it is drawing is 4 ampere. With the help of this, with the help of Ohm's law, we already know that V is equal to IR. So we can easily calculate R is equal to V upon I. That will be equal to 60 upon 4. That is equal to 15 ohm. Now, according to question, the new potential difference is 120 volt, and we need to calculate current I. What will be the I? In the same wire, this, if the wire is same, the resistance will be 15 ohm. So what we need to do is applying Ohm's law again. V is equal to IR. Now I is equal to V upon R. What is the V? 120, and what is R? 15. So it will be cancelled by 8. So here it will be 8 amperes. Is that clear, Hamna and Harsha?
Yes, sir.
Okay, moving to the next question. Uh, since we didn't practice any question in the last class, that's why I'm giving you questions in this class. Next question is, write the question with me. Resistance of a metal wire of length 1 meter. 1 meter length is 20 ohm. If the conductor is 1 meter long, the resistance is 20 ohm at 20 degrees centigrade. At 20 degree centigrade. If the diameter of the wire, so if the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? We need to calculate resistivity, that means rho, specific resistance, also known as resistivity, is also known as specific resistance. This is 26 ohm. Just write it, not 20, make it 26 ohm. Can you solve it, Hamna and Harsha?
Sir, can you explain?
Okay. Just say whatever is the given, just focus on that. Resistance, since resistance is given 26 ohm, length of the wire is also given, that is 1 meter. Temperature is constant, that means that's good. And diameter is 0.3 mm. What will be the radius? 0.33 by 2 mm, right? Is that
Yes,
clear?
sir.
Now, what will be the resistivity? That means rho is asking. And what I just told you about a formula, R is equal to rho L by A. That means rho will be equal to R into A upon L. Is that clear?
Yes, sir.
And we write this, R is given, L is given, area. Since diameter or radius is given, we can easily find out the area. Area is equal to pi r square, right? Pi, we know the value of pi, that is 3.14. Radius in millimeter and length in meter. So what we need to do is convert this millimeter into meter and just square it and put the value. It will be converted into resistivity. Is that clear?
Yes, sir.
So just convert 0.3 mm, 0.33 by 2 mm into meter. That will be 10 raised to the power minus 3, right?
Yes, sir.
Okay, just solve it, please. So it will be like 0.33 by 2 into 10 raised to the power minus 3 pi r square. Basically, wait a minute. I'm going to put the value as this is 26 and this is pi r square upon length is 1. So it will be 26 into pi, that is 3.14, and into what is the radius? 0.33 by 2 into 10 raised to the power minus 3 ka whole square. This is in millimeter. If you are going to convert it into meter, it will be multiplied or divided by 10 raised to the power meter. Amna, is that clear?
Sir,
Can you
why
solve
square
this
it?
question? What is the value of, what is the formula of area of a circle?
Pi r square.
Pi r square? Yes or no, Harsha?
Yes, sir.
So I just put the value of pi, that is 3.14, and r square. What is the value of r? You can see the value of r is this, and since the formula says r square, that's why I just squared it. Okay.
Okay, sir.
Okay, just write it and let me know if you're done with this. Then another question, then we will move to the next topic, which is resistance of a system of resistors.
Sir, should I solve it further?
You will solve it at home. I'm going to give you another question. Hamna, are you done with this? Hamna is unable to speak. Okay. Next question on this topic is, wait a minute. Okay, write the question with me. A wire of given material having length L and area of cross section A has a resistance of 4 ohm, has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and area of cross section 2A? This is very important question. Please try, and if you are unable to solve it, let me know. I will solve it. Same wire, we are talking about same wire. Length is in starting initial length is L and area of cross section is A, has a resistance 4 ohm. What would be the resistance of another wire of the same material? That means the material is same. That means resistivity is same. I told you that resistivity is same. The resistivity is specific for a given wire. Different kinds of wire has different resistivity, but same kind of wire has same resistivity. Harsha, can you do this or I should do it?
Sir, 1 minute, sir.
Okay.
Sir, 1/4 times the first wire.
No, it's given. So it will be numerical value. Just see. R1, I'm taking as R1. R1 is basically rho L by A. This is the formula. And since it is given length is L and area of cross section is A, so we don't need to change. Rho is rho. Also, R2, and it is also given that R1 has a value 4. I will put it later. Okay. R2 is equal to rho will be same because it is of the same material. Now, what about length? Length is half. And what about A? Area of cross section is double. Area of cross section is double. There are two equations now. Now, what we need to do is, with the help of this equation, I'm going to solve it. Like I'm going to take the ratio 1 by 2. So R1 upon R2. And it will be equal to, can I solve this like this? Can I write it like this? Can I write it like this? This will be equal to rho L upon 4A. Can I write this,
Yes,
Harsha?
sir.
Amna? Okay. R1 by R2, that will be equal to rho L by A upon also rho L by 4A. Now going to solve it, rho will be cancelled by rho. Now what we are going to do, L by A into 4A upon L. L will be cancelled by L, A will be cancelled by A. Now we know that R1 is given as 4 ohm. So going to put the value of this as 4 upon R2, that will be equal to 4. And you can easily calculate it. 4 will be cancelled by 4. R2 will be equal to 1 ohm. Just write it. हाँ.
Sir, I did it in a different way and got the same answer.
You got the same answer, right?
Yes, sir.
But you don't get this, right, Harsha?
Sir?
Uh, are you able to understand it, or should I explain it again?
No, sir, understood.
Okay, very good. You just didn't put the value of R1, right? That's
Yes,
why you
sir.
got true. Okay. Amna, do you have any doubt in this? Can we move to the next part?
Yes, sir.
Okay. Moving to the next part. Now we are going to see write a topic, that is resistance. Resistance of a system of resistors. So we are going to see resistance of a system of resistors. There are two system of resistors we can arrange. The first one is two system. Basically, the first one is series and another one is parallel. There are two systems to arrange the resistors. The first one is the series and another one is parallel. See, how will we recognize whether it is series or parallel? In series, resistor is basically group of resistances. Okay, series is see, when resistor are arranged in series, that means current flowing through resistors are same. That means if resistors are arranged in series, each resistor will have same current, same and equal current, but potential difference PD will be different. PD will be different. Now, what is parallel? Current flowing is different. Current flowing is different from different resistor. And also, second point, PD will be same. PD will be same. This is how we are going to recognize whether whether resistors are in series or parallel. Just write it, then I will show a representation. It will be more clear to you.
Done, sir.
Very good. Now see, what is resistance? How will you going to recognize it? Basically, I'm going to represent resistance with series and with parallel. This is the symbol of resistance. Here is ammeter and here is batteries. Here is the switch and current is flowing through this. I current flowing through this. You know that this is R1 resistance, this is R2, this is R3. You can see if current I is moving through this wire, this I will pass through every resistance. That means this different resistance or same resistance R1, R2, R3 will have same current passing through it or not. If I is going from here to there, then it means I is moving through R1, R2, R3. That means same current flowing through different resistance. That is basically that is series. Okay, please write it. So what I want to say is that current moving is same through each resistance will have this representation is basically for series. Is that clear, Harsha?
Yes, sir.
Now see what is parallel resistance or resistors. I'm going to represent. You can see this is R1, this is R2, this is R3, this is a, this is batteries, this is the switch. Now see, this is positive terminal, this is negative terminal. Current will go like this. If current will reach here, this current will have three different paths to travel. Now you can see this I will be distributed into three parts: I1, I2, I3. Since all are wire, all are conductor, this I will be divided into three parts, and you can see different current will flow through this R1, R2, R3. This type of scenario is basically parallel resistors. Is that clear?
Yes, sir.
Now, one more thing is very important. This is voltmeter. This is voltmeter. If you are going to see what is the voltage of this, you know that V is equal to IR. So if you are going to apply on this R1, V is equal to IR1. If you are going to apply on this, it will be IR2. And if you are going to find voltage at R3, IR3. That's why I wrote it potential difference or voltage will be different in series. You can see IR1. I is same, but R1, R2, R3 are different. That's why the potential difference will be potential or voltage will be different for each resistor, each resistance in series, but in a parallel resistor, in a parallel resistances, potential difference will be equal. Potential difference will be equal. So just write it and then I will again explain it. Abdullah, why were you late? Why are you late?
Sir, I just arrived from school, sir.
Okay, okay, no problem. Done.
Yes, sir.
Now see, it is very important to note that in series combination, in series combination, current flowing is same. In series combination, yes, current flowing is same, but PD will be different. In parallel combination, current flowing different, PD will be same. Okay, so now I am going to show you how to calculate equivalent resistance. Equivalent resistance. This is very important. Equivalent resistance. If you are asked what is the total current, so for current I is equal to V upon R, and here R should be equivalent. That means total resistances in the circuit. So how to calculate series resistance? You know that V is equal to V1 plus V2 plus V3. This is the simple formula. V is equal to, here will be V1, V2, V3. Now we know that V is equal to IR. So I'm going to apply IR. Here, since it is talking about V1, so it will be IR1. Since 2, IR2. And here it will be IR3. Since current is same, so you can easily take common I as this R1 plus R2 plus R3, and I will be cancelled, and you will get a value that is R is equal to R1 plus R2 plus R3. Whenever resistors are arranged in series combination and you have to find the equivalent resistance, then what you need to do is add all the resistance, you will get equivalent resistances. Please write this. Are you done with this? Abdullah, Harsha, are you done with this?
Yes, sir.
Yes, sir.
Okay, now see how to calculate equivalent resistance in parallel. So we know that I just show you that I current is divided into three parts. You can see I is equal to I is divided into three parts: I1, I2, and I3. So can I write this as I is equal to I1 plus I2 plus I3? Can I write this,
Yes,
Harsha?
sir. Yes,
Since
sir.
I is divided into three parts, and we know that I is equal to V upon R, so it will be V upon R. And since we are talking about I1, so it will be V upon R1. See what is the difference, since V is potential difference, and potential difference in parallel resistance or parallel combination are equal. And here it will be V upon R2, again V upon R3. Now V upon R will be equal to, I'm going to take V as a common, 1 upon R1 plus 1 upon R2 plus 1 upon R3. And what we need to do, cancel this, and it will be 1 upon R. This is equivalent 1 upon R1 plus 1 upon R2 plus 1 upon R3. These concepts are very important, and questions has been asked, very important. Please do this. Then I'll give you some questions.
Done, sir.
Everyone done with this? Now see how question will be asked. Calculate equivalent resistances. Equivalent resistance of following. Equivalent resistor, you can say, of following. The first one is like this. This is 4 ohm. This is 3 ohm. This is 3 ohm. First, we need to check whether it is in series or parallel. One ohm, 1 ohm, 1 ohm. See, I'm going to explain it. Then I will give you some homework. Then you will practice. Okay, Harsha?
Okay, sir.
Sa, Abdullah, Hamna. See, current will start from the positive terminal, and how we will recognize whether it is positive or negative. The big one is positive and the smaller one is negative. So see, start from current will start from positive one, I. You can see all the from all the resistances I is passing. That means current is same. That means all these resistances are in series. So R equivalent will be equal to 4 plus 3 plus 3. That will be equal to 10 ohm. Is that clear, Harsha? It is very
Yes, sir.
easy. Now see, if you are going to, this is positive and this is negative, current will be like this. I is going. Now see, I and then I1 and then I2. Is that clear?
Yes, sir.
Now see, 1 ohm and 1 ohm. Is this in series or parallel?
Parallel.
Parallel. So we are going to calculate this part only first, this part. So what will be it? 1 upon R1 will be equal to 1 upon R1 plus 1 upon R2. So you are going to solve it 1 upon 1 plus 1 upon 1, that will be equal to 2 by 1, right? So 1 by R is equal to 2. So R is equal to 1 by 2 or not?
Yes, sir.
Harsha? So it will be 1 by 2. Now see, this is converted into, important, very important. This is converted into, now this is 1 ohm already. Now this combination is converted into half ohm, and it is like this, half ohm. Now see, I and then I. Now this 1 ohm and half ohm is in series or parallel?
Series.
Series. So what we are going to do, R equivalent is equal to 1 plus 1 by 2, that will be 3 by 2 ohm. This will be the final answer. So what we did here is, these two are in parallel, so we are going to solve it and make it 1. So when you make it 1, it will be series with this resistance. Is that clear?
Yes, sir.
Okay, just write it. Done.
2 minutes, sir.
Okay, okay. Take your time.
So, sir, after solving a parallel resistor, we can convert it into a series.
Yes, yes. This both are combined into this. Now this both will look like series combination.
Yes, sir.
Okay.
Done, sir.
Is it done, Ram? Okay. So we are going to start. We are going to end this chapter in the next class. Before that, I will. I will give you some assignment. Okay. In this Sunday, which chapter you are